Okay, you got two non-perfect radicals there. So you got square root of 75 plus square root of 27. Bam. As they are, you cannot add them. Okay? And because it's being added, you can't do that mush them under the same radical trick. That only works with multiplication or division. Okay, so now we have to find if we can break down 75 and or 27 into a factor of something with one of the factors being a perfect square. So what two numbers, when you multiply them, are 75, and one of them is a perfect square? First thing that pops in my mind is 5 times 5 is 25 times 3. Okay? And for the 27, 27 is 9 times 3. 9 is a perfect square. 25 is a perfect square. So we're going to change 25 and 9 into 5 squared, 3 squared, respectively. Now, if you multiply that out, that's still 75. You multiply this one out, that's still 27. But now here comes the rule when you're factoring under the same radical. You can break them down into their own little houses. Kabam. Kaboom. Now we know what the square root of 5 squared is, and we know what the square root of 3 squared is, right? The radical is going to cancel out with the exponent of 2. Let's get some working room here. Got it? Bam. So let's rewrite this a little bit. This is just going to be 5 times the square root of 3. We don't put that little time symbol in there. We just write it right next door. But now one more step, you'll notice that the radical, square root of 3, is a factor of both of them. So we're going to do a little bit of distributivity. We're going to take these, we're going to treat these like variables. In other words, if this was 5x plus 3x, we would have 8x. But it's not x, it's the square root of 3. So that's the answer, 8 times the square root of 3. Hope that it. Hope you got it. Bibbidi-bibbidi. MGZ out.